For this section, 4.9, graphing and solving quadratic inequalities, we're actually going to do the video in two pieces. So this is the first half of this particular lesson. What we're going to look at will be the possibility of your equations being in standard form, ax squared plus bx plus c, but it could either be the less than or equal to, greater than or equal to family, like these, in which case you need to remember to draw your graph with a solid line, or it could be the less than or greater than symbol, in which case you need to remember to graph with a dotted line. When you do your graphing, what I'd like you to do is pick a test point, and 0, 0 is the easiest test point to try. And then you'll decide, based on that 0, 0 test point, will you shade inside the parabola or outside the parabola? Let's try this first one right here. Y is less than negative x squared minus 4x. Now it might be a smart idea right away to look at your symbol and note that the symbol requires a dotted line. To graph this, you've got a couple options. You can either factor, or you could try your negative b over 2a format. Doesn't make any difference which one you try. Factoring might be easier for some of you, in which case, let's try that. We'll take out a negative and the x. That leaves us with x plus 4. When we factor it in this format, we're going to solve each piece. Negative x equals 0. And the other piece, when we take it out, solve it separate, we get x equals negative 4. These are the two x-intercepts, and I can then put these two spots on our graph, like so. Now I'm going to need a vertex out of that. Vertex, you could either do halfway in between, or you could do negative b over 2a. It doesn't make any difference. These numbers are fairly easy. Between 0 and negative 4, halfway in between is negative 2. This is our p plus q over 2 rule. 0 plus negative 4, negative 4 over 2, negative 2. And then remember, we plug it in. So I need the negative of negative 2, and then negative 2 plus 4. 2 times 2, 4. Negative 2, 4 is going to be my vertex up here. And then I can connect. Now remember, we made this little note that said that we would connect this with a dotted line. And we'll draw in my dotted line. And then I'm going to have to decide my shading. Now 0, 0 is not available with this one, since 0, 0 is right on the graph, which means I'm going to have to try a different test point. Let's pick something obvious. You could go inside the parabola. You could pick something outside. I want to pick something out here. 2, 0. I don't have a negative number. It might be easier for some of you. I'm going to plug that back into the original and see if I get a true sentence or not. Y term is 0. Is this less than negative of, my x number was 2, 2 squared minus 4 times 2. Is 0 less than the opposite of 4 minus 8? Is 0 less than negative 12? Is 0 less than negative 12? That answer is no, which means this point is not going to be shaded, so don't shade outside. We need to shade inside. And that's how we solve the inequality with graphing. Now let's look at this next one. We're going to solve the system with graphing. System means we've got two equations. Our first one, y is greater than x squared minus 9. Our second one, y is less than or equal to negative 2x squared plus 4x plus 2. All right, so the first equation I want to look at is y is greater than x squared minus 9. You should hopefully recognize that this is a difference of two squares, x plus 3, x minus 3. That gives me my two intercepts, negative 3 and 3. I can put those 2 points on my graph right away, negative 3 and 3. Then I have to find halfway in between to get my vertex. So halfway in between is 0 for the first part of my vertex. And then if I plug 0 back in, I get 0 squared minus 9, and negative 9. So my y coordinate is going to be negative 9. Way down here. 0, negative 9. I can connect these together, and be careful when you connect. This inequality, remember again, is a dotted line. So I'm going to connect, remembering to do the dotted line. And then I'll decide my shading. 0, 0 is available for me to test, since 0, 0 is right here. So I'm going to plug in the numbers and see if I get a true sentence or not. Is 0 greater than 0 squared minus 9? Is 0 greater than negative 9? That answer is yes. So I'm going to shade inside here. My second equation, I'll use a different color. My second equation, less than or equal to negative 2x squared plus 4x plus 2. If we try our vertex, negative b over 2a, I've got negative 4 over 2 times negative 2, which is negative 4. That's 1. So my x coordinate is going to be 1, and then plug it in. Negative 2 times 1 squared plus 4 times 1 plus 2. Negative 2 plus 4 plus 2, 2 plus 2, 4. My vertex is at 1, 4, right here. For this one, I can use an intercept, a y-intercept of 2, that's my c value, 0, 2, y-intercept, right here. And then I'm going to use my projection. So we know that we've got a line of symmetry right there, axis of symmetry. So if I could project my y-intercept to the other side, puts me right here. I've got my 3 dots, and I can now graph this. This graph will be a solid line. So I'm going to go this way, solid line, and I'm going to make these nice and long so all of my legs intersect each other. And then I have to decide my shading. Pretty sure that 0, 0, sorry for that interruption. Pretty sure that 0, 0 is not going to be on my curve. 0, 0 will be my test point. Is 0 less than or equal to negative 2 times 0 squared plus 4 times 0 plus 2? Is 0 less than or equal to 0 plus 0 plus 2? Is 0 less than or equal to 2? That answer is yes, which means 0, 0 is included in my test point, so I will shade inside the legs of this parabola. Now, since I have to shade, or I'm looking for the system, that means 2 of them on the same graph, I have to decide where do I see both green and blue at the same time. So if you look very carefully, I'll outline in a different color. We've got here, and then it goes down until I get to where they cross. It'll curve up here, hit this other parabola, and then come back up again. So it's kind of a weird hot dog shape. That will be my overall answer for this particular system of inequalities. All right, so that'll be the end of our first graph, or our first video, looking at solving with graphing.